Dear viewers, suppose we calculate the reactions of a beam perfectly and every force balances and Newton's law for equilibrium, all the equations of equilibrium are satisfied. Is the beam is the beam safe? Can we see with certainty that the structure is safe? Surprisingly, no. A structure can satisfy every equilibrium condition and still bend excessively and fail without warning sometimes, and sometimes with warning. But today we will discover how it happens. I mean, how can we make a balanced structure? The simplest structure to support the load, a central load. Okay? The simplest model for it, a beam that I'm going to draw here with two supports at the end, one here and the other one here. It's the simplest structure. And here's a load itself, a central load. Now we make its FBD. FBD of this structure is a central force, applied force here, and these supports are actually keeping the beam from falling down. So that's why the forces of reaction, they should be in the opposite direction. I mean, if the beam is about to fall down, the support reactions must act upwards. And our sign convention is here. All upward forces are positive and all forces towards right are positive. So what will we do? What we need to do? I'm not trying to teach you a formula or trying to solve a textbook problem. We're just exploring it together. Just think. We're trying to think about the situation. And in this situation, the forces, the reaction forces, they are our defenders. They are defending our beam or our structure. They are crying for help. Or they are crying or shouting that here, it is about to fall, it is about to fall without us. And we are here to support it. We are here to support it. Just imagine, it's the support is like our shoulder. We have something on our shoulder trying to push us down. And we are not letting it fall. So if we remove our shoulder from underneath it and we call a man, we call another thing to stand on our place, what's that? That will exert an upward force on it. Okay? That is our representative. So let the support is our body. We remove ourselves, or we remove the beam from all the surrounding supports. What will happen? There should be something that will not that will resist its downward motion, And that is the reaction. We call it reaction. So the reaction is, we can say the reaction is our replacement, our support's replacement. And now we draw it here. And that replacement should be in the direction opposite to the direction in which the body is about to fall or expected to fall, or the tendency, the direction in which it has a tendency to fall or move. So the reaction must be opposite to that tendency. And that is obviously that the tendency is to move downwards. So the reaction will be opposite to it. I mean, in the positive y direction, upwards. So here, I'm applying force. One force here for one support, and the other force here for the other support. Okay. Name it. We name it. Let's say it's A. It's B. So this one is AY. This one is BY. Okay. So now we have an equation, a very important equation. A very important equation that will help us to see if our supports are sufficient. Are they sufficient to keep this beam from falling? So we introduce it here, and that is the force from above. I mean the central force, the applied force. It must be at least, and we can say, and at most, equal to the support reactions. So in short, we can say that sigma Fy, I mean sum of all the forces in the y direction, that is equal to 0. So negative force, I mean because this is downward, that's why I call it negative, plus By plus Ay is equal to 0. So if I move it there, if I move this F there, it will become Ay plus By is equal to F. So this equation will tell us that our beam will not move down. It is safe. And if our load is excessive and it exceeds the sum of Ay and By, we can expect a kind of fall or a kind of movement in the beam, probably in the y direction, I mean the downward direction. So this equation is telling us that you're safe, you're safe, you're safe. But the main question is still there. The question from where I started this video is that if these supports do not change their place, they are there, steam here, the two ends are holding their position, but the bending, I mean the bending in the beam is so great, so big, that we fear the beam might break from the middle, from anywhere in its span. So the main question is still there, and this equation does not give us the answer of that question, but we are pursuing the answer. We'll pursue it. Stay with us, keep watching us. We will find the answer of this big question. Thank you. Bye.